Question number 4, I'm going to just put in brackets here. This would be a non-calculator question. I mean, if it was a calculator question, you could just type it in your calculator, push enter, and get an answer, which would be nice and straightforward. However, in a non-calculator, the first thing I hope you notice is that it's not nice. Remember, log solve for an exponent, so I have to like put a little tiny question mark beside there in the exponent. I'm like, 9 to what exponent is 6? Ugh. A 9 to what exponent is 72? Those are not on your powers chart at all. So it seems like a problem, but what we're going to do is we're going to write as a single log and see if that helps us. So if I wanted to use my log laws, I can't do the subtracting yet because of that extra 3 out in front. To write as a single logarithm, first of all, I'd have to put that 3 in as an exponent. Then I'm subtracting. So the positive 1 is going to be in my numerator. The negative 1 is in my denominator. And inside the brackets there, we need to simplify. Option 1 for simplifying is to multiply everything out and then simplify it. You would get 216 divided by 72. Not an easy fraction to simplify, but you could do that. But personally, I'll show you that sometimes if you break things up, so instead of multiplying 6 times 6 times 6, I'm just going to write it out. That's 6 times 6 times 6. 72 is 36, which is 6 times 6 times 2. And then I'm like, ooh, yeah. Things simplify nicely. All those 6's will cancel out. And then we're just left with 6 divided by 2, which is log 9 of 3. And you have 2 options from this point, because we still need to evaluate. Evaluate means come up with a number. Some of you might know what the answer is, then just write it down. That would be perfectly fine. But if you look at this and you can't go, nothing comes to mind quickly when you say 9 to what exponent is 3. That's not quick in your mind for mental math. Then we can use the same strategy we used earlier. Remember when we're like trying to evaluate these and we said let x equal this? And you could say, well, the base is 9, x is the exponent, equals 3. Are those in the same column on my powers chart? Yes. I can change 9 to 3 squared. And that would give me 3 to the 2x equals 3, which is technically 3 to the 1. These are the same, so 2x would have to equal 1, and x would have to equal a half. Now that you know the answer, do you think you could see a half? Right? What is an exponent of a half again? That's a square root. Does it make sense that the square root of 9 is 3? So could you go directly from here to the answer? But then it's nice if you can't. We have the technique that we developed before, where we change it to exponential form, use our powers chart, and we can solve it that way as well. So it's kind of nice to have a backup in case you can't see something. But it would be perfectly fine just to go directly from there to say that it is 1/2. All right, let's do part B, same kind of idea. Make a loud camera noise. There we go. And it supposedly took a picture of it. We'll try that again. Another loud camera noise. There it is. Nice and clear. If you're wondering if you need glasses, don't look at that. Again, non-calculator. We're going to try to put this together. Step 1, put in all the numbers in front as exponents. And then as the shortcut, whatever is, first of all, I notice they all have the same base, so I'm allowed to use my log logs. And whatever is positive, that'll be the 6 squared, and the 12 will be in my numerator, and 3 cubed will be in my denominator. And again, instead of multiplying it out, I would probably leave my 3's like this. 6 is 3 times 2, and the other 6 would be 3 times 2, and the 12 is 3 times 4. So all my 3's nicely simplify away. And 2 times 2 times 4 is 16. Is this one you can do? 4 to what exponent is 16? That's 2. And circle question 13 for practice.